Hello everyone, thank you for coming to our project presentation. We are from FS 10428. We are Jang Manho, Zheng Weiyang Ryan, Han Zhenlai, and we are the 4 group leaders of the module DVE. From semester 2 to 3, our class have done a project with an aim to create smart mobile robots using the 3 knowledge that we have learned from the mechanical and electronic department. So in this presentation, we are going to walk you through the production process of the robot.
Here's the agenda of our presentation. Now, let me tell you the background and purpose of our project. A robotic competition Battle Sumo will be co-organized by ProAct Training and Development Center, Mechanical and Electronics. Our class is invited to participate in this competition. We have 20 students in class and we are divided into 4 groups. Each group has to design and build a smart mobile robot which is able to move objects to a specific area within a time limit. That's to say, our robot has to push another robot of the other group out of the arena.
The competition organizers have listed out some criteria. The robot should not be bigger than 30 cm by 30 cm by 35 cm. The battery should last at least 2 hours. The robot should have connectivity with Bluetooth or Wi-Fi so that it can remotely control it by smartphone application. The robot should be able to move forward and reverse, turn around, and grab or push objects.
All groups adopt similar approaches when doing this project. First, we watch some videos of different types of sumo robots. After further discussion, we decide the design of our robots and then we draft the robots by hand. After that, we used SolidWorks to make a 3D design. Our teachers then gave us comments to revise our design. In the meantime, we did the electronic parts by welding the circuit board and trying to develop a firmware to control the robot. After having the mechanical and electronic parts ready, we assembled them together and do some tests. That's it for the talking part. Now, let us show you all our robots.
The size is 240 mm by 200 mm by 150 mm. Second, the outer shell is mainly made of the organic steel. It weighs 2 kg and the color is black.
It has an appearance of a claw. The size is 15.5 cm times 14.6 cm times 11 cm. Second, the outer shell is mainly made of PLA. We also use some electronics and mechanical parts to make the robot able to move.
It is a cat head-shaped robot. The size is 160 mm by 180 mm by 65 mm. Second, the robot is made of PLA and acrylic. There are some gear motors, wheels, board, and battery assembled with the robot. Also, there is an acrylic cover on top of the robot to protect the important electronic parts. Besides, the robot can be moved around on the cart and push bottle and another robot away by using smartphone app to control.
It is a trapezoidal Battle Sumo robot. The size is 25 cm by 14 cm by 7.5 cm. Second, the outer shell is mainly made of PLA. We used 3D printer to print the body of the robot. The ESP32 also enables us to control the robot remotely by connecting with smartphone and using Android app. Our robots look pretty good, right? But it has been a long way for us to have the robots done. During the process, we faced many challenges. Let us tell you some of the challenges and how we solved them.
Although we learned how to use SolidWorks, we had experience in using it to do our web project like this one. Sometimes we were too idealistic that our 3D models design would fit the 3D printer, but turned out it was not. Therefore, we spent much time in design, make consultation with teachers. Before it was successfully printed out.
Our biggest challenge is similar to that of Group 1. Perhaps we were too creative. Some of our design did not meet the requirements, that is, the overall size is too big. So, we spent extra time to redesign the robot. Luckily, our teachers gave us a lot of useful suggestions and learned a lot from them.
I think we had the skills to create a 3D model, but we lacked design skills. Just like the previous two groups, our design either was too big or did not fit the electronic parts. Thanks to the teachers, they gave us good suggestions and advice on how to carefully design our robot.
Let me tell you something different. The 3D printers at the 3D printing studio sometimes didn't work well, and we need to restart the printing again and again. As time was short, I decided to buy a 3D printer on my own so that we could finish the project on time.
To conclude, although we finally made our robots, we know that the robots are imperfect because we lack the required design skills and technical knowledge. We also think that we have poor management skills, which made us finish our robots in a rush towards the end of the semester. All this gave us a great opportunity to understand ourselves better. We also learned a lot of skills and gained valuable experience for our final year project. That's the end of our presentation. We hope you all enjoy.